In recent years, Elon Musk has consolidated himself as the visionary mind that challenges the limits of technology and innovation. Whether in the auto industry, space exploration, or artificial intelligence, Musk always surprises the world with ads that radically change the course of the future. And this time was no different. With a fixed look in the future and an approach that mixes boldness and practicality, Elon Musk took the stage to reveal a novelty that promises to redefine industry standards. The silence in the auditorium was quickly replaced by expectation murmurs, while the spotlight turned to Tesla and Spacex CEO. Today we are about to take another gigantic step to a sustainable and technologically advanced future, said Musk, with his usual tone of confidence and enthusiasm. He knew his ad would echo globally, mobilizing engineers, investors, and technology enthusiasts. What came next was a combination of innovation and strategy, something that only Elon Musk could conceive. Its ability to transform apparently impossible ideas into reality not only attracts public attention, but also redefines entire industries. The audience eagerly awaited as he detailed how this new technology would change everything we know. From the first teasers to the latest prototypes presented by Elon Musk, Tesla Optimus has evolved quickly, making it clear that Tesla is not just creating a robot, but redefining the future of automation. Optimus is not a common humanoid robot. It is designed to learn and adapt, becoming more efficient as it interacts with the environment. Its mild structure, built with advanced materials, allows a balance between strength and agility, enabling from simple tasks, such as carrying boxes and organizing stocks, to more delicate operations such as handling fragile objects. Equipped with an artificial intelligence system based on the same technology as Tesla's autonomous vehicles, Optimus is able to interpret the space around it, recognize faces, predict movements, and make decisions without human intervention. This sets him apart from traditional industrial robots, which depend on rigid programming and controlled environments. One of Optimus's most impressive features is its communication capacity. He can respond to voice commands, interpret gestures, and even predict needs based on behavioral patterns. Imagine a robot you understand when you need to get an object for you, even before you ask you. In addition, its energy autonomy is one of the great differentials. With an efficient battery and optimized energy consumption systems, Optimus can operate for long periods without frequent recharge, making it a viable solution for both homes and industries. But this is just the beginning. Tesla has already suggested that future versions of Optimus will have even more autonomy, enhanced strength, and deep integration with the Tesla ecosystem, connecting to cars, power systems, and even smart houses. Now that we understand its abilities, the big question is, how will Optimus impact the market and society? Let's explore this below. Tesla Optimus's great revolution is not just in its futuristic design or its ability to perform physical tasks. The true technological leap happens in the heart of the robot, its artificial intelligence. Combining advanced neural networks, deep learning, and real-time processing, Optimus stands out as one of the smartest humanoid robots ever created. From the first prototypes, Tesla has refined Optimus AI to make it more autonomous and efficient. Using the same artificial intelligence architecture that feeds full self-driving FSD systems of Tesla cars, the robot is able to map environments, interpret commands accurately, and even anticipate actions based on human behavior. One of the greatest innovations is in continuous learning. Optimus not only follows a fixed schedule, but evolves as it interacts with the world around it. He learns patterns, improves his motor coordination, and refines his ability to recognize objects and people. This means that over time, it becomes more efficient in daily tasks, whether in the domestic, industrial, or commercial environment. Another crucial breakthrough is the capacity for natural interaction. Thanks to the use of advanced natural language processing models, NLP, Optimus understands complex commands and can keep dialogues increasingly fluid with humans. He is not limited to obey basic instructions. He understands contexts, answers questions, and even suggests solutions to problems. The computational view of Optimus is also a differential. With high-definition cameras and sensors deal with, it not only sees, but interprets the environment in 3D, identifying obstacles, calculating safe trajectories, and adjusting its posture to avoid collisions. This is essential for your autonomy and efficiency in dynamic places such as factories and warehouses. And Tesla doesn't stop there. Elon Musk has already said that future software updates can be made remotely, allowing Optimus to receive constant improvements without being replaced. This ensures that each unit can become more advanced over time, always remaining at the forefront of artificial intelligence. With the rapid evolution of Tesla Optimus, one of the most frequently asked questions is, how much will it cost, and when will it be available on a large scale? Since the initial announcement, Elon Musk has reinforced that Tesla Bot's big goal is to be accessible and produced in large quantities. But making an economically viable humanoid robot is not a simple challenge. Tesla aims to follow the same production model that has revolutionized the electric vehicle market: manufacturing efficiency, cost reduction through innovation, and extreme scalability. In other words, the idea is not to create an exclusive robot for billionaire companies, but make it accessible to ordinary consumers and medium industries. Musk has already suggested that Optimus's starting price can be around $20,000, a surprisingly low value for a humanoid robot with advanced abilities. To put this in perspective, it is less than a popular car in the United States and far below the cost of other competition robots, such as Boston Dynamics models. This aggressive price will only be possible thanks to an optimized manufacturing process, which involves large-scale production, component standardization, and Tesla expertise use in the manufacture of integrated hardware and software. Mass production will be a watershed for Optimus. Currently, the first prototypes are being tested internally at Tesla, performing simple tasks within the factories. But to achieve an industrial pace, the company will have to invest heavily in the automation of the robot's own assembly line. Another crucial factor for cost reduction is the use of existing components in Tesla vehicles. The processor, the batteries, and even some sensors are the same used in the company's cars. This not only decreases the cost of production, but also facilitates maintenance and future updates. However, there is a big challenge ahead: demand. If Tesla Bot is released at a competitive price and fulfilling promises of efficiency, global interest will be gigantic. Musk has already mentioned that production volume will need to be expanded quickly to fulfill orders from companies and consumers. If this happens, we can see factories dedicated to the production of Optimus being erected, just as Tesla built gigafactories for its electric vehicles. The path to Optimus mass production is being paved, and Tesla has a clear strategy to make it a reality. But how will society react to the introduction of these large-scale robots? And what will be the impacts on the economy and the job market? Behind Tesla Optimus's futuristic appearance, there's an impressive combination of state-of-the-art technology and precision engineering. Unlike traditional robots, which depend on extremely expensive and custom components, Optimus follows an innovative approach. It makes the most of Tesla's technologies already developed. This not only reduces production costs, but also accelerates robot development and reliability. Optimus's brain is fueled by Tesla's artificial intelligence chip, the same advanced processor that equips the company's vehicles for autonomous functions. This hardware allows the robot to process real-time data, make complex decisions, and improve its performance through machine learning. In addition, Tesla uses advanced neural networks that allow Optimus to interpret the environment accurately and naturally respond to human commands. Another revolutionary aspect of Optimus is in the actuators and electric motors that simulate the functioning of human muscles. Unlike hydraulic systems, which are noisy and require constant maintenance, Tesla's electric actuators provide more fluid, silent, and efficient movements, making the robots safer and reliable for everyday tasks. To see the world around it, Optimus has a system of high-precision cameras and sensors derived from the full self-driving FSD system of Tesla cars. These cameras work in conjunction with computational vision algorithms, allowing the robot to identify objects, people, and even understand subtle gestures. This technology is essential for Optimus to interact intuitively in domestic and industrial environments. The energy of the robot comes from a compact and high-density battery, strategically positioned on the trunk to optimize balance and weight distribution. This battery is based on the same technology as the cells used in Tesla cars, ensuring enough autonomy for a full day of work without frequent refill. In addition, Tesla is developing more intuitive neural interfaces so that Optimus can be operated simply and efficiently. The idea is that it can be controlled by voice commands, applications, and even more advanced systems in the future, as integration with personalized artificial intelligence. Each component of Optimus is designed to transform the concept of science fiction humanoid robots into an accessible and functional reality. But with so much technology involved, a big question arises. To what extent can Optimus replace human work? This leads us to the next topic. For Tesla Optimus to be really useful and accessible, it needs to be highly efficient in energy consumption, and that's exactly what Tesla has focused on. Instead of depending on complex and poorly optimized energy systems, the robot uses a high-energy battery based on advanced technology already employed in Tesla's electric vehicles. This battery, strategically located on the Optimus trunk, not only provides energy to all its functions, but also contributes to the balance and stability of the robot. Its capacity is designed to ensure up to a whole day of operating with a single load, allowing the Optimus to perform prolonged tasks without constant interruptions for recharge. But the autonomy alone would not be enough without an intelligent energy management system. Therefore, Tesla has integrated with Optimus an optimized architecture of energy consumption, where each component, from the electrical motors of the limb to the vision sensors and artificial intelligence, operates extremely efficiently. Thus, the robot can minimize waste and maximize battery life, becoming more economical and functional. Another essential factor for Optimus's energy efficiency is in its intelligent movement. Robots' electric actuators are designed to consume as little energy as possible, taking advantage of biomechanical principles and natural balance. In addition, Tesla has implemented an energy regeneration system, similar to that used in the regenerative brakes of the company's electric cars. This means that whenever Optimus reduces its speed or change position, part of the kinetic energy is recovered and stored on the battery, further expanding its autonomy. And the loading? Tesla promises a quick and efficient recharge, allowing the robot ready for use within hours. Although the company has not yet revealed details about the exact loading method, Optimus is likely to count on wireless solutions or induction loading, eliminating the need for cables and facilitating its integration in domestic and industrial environments. With a perfect balance between power, autonomy, and efficiency, Optimus not only becomes a viable robot for repetitive and auxiliary tasks, but also represents an important step in the evolution of sustainable robotics. But with all this technology, an inevitable question arises. How does Tesla intend to ensure that Optimus is accessible to the public?